This is our presentation on hydroelectric power and tidal wave energy.
I'm Matthew Ho.
I'm Kevin.
I am Andy Vuong.
Hi, I'm Michael. So what exactly is hydroelectric power? Is it Blastoise's special move that soaks you from head to toe? Well, actually, hydropower is the electricity produced by dams from the power of running water. Over here is a picture of a dam. This is where electricity is produced with the help of a river. But how exactly does this work? Well, there are two ways a dam works: storage technique and run-of-river approach. In storage technique, typically there is an elevated reservoir behind a dam which stores water. As water flows from the reservoir and through the dam, the headwater turns a turbine along the way before coming out the other side as tailwater and into the afterbay. The turning of the turbine powers generators, which in turn create electricity that is transferred by the power lines for storage or use. The run-of-river approach is very similar to the storage technique. In fact, they are pretty much the same thing, except in the run-of-river approach, instead of creating a reservoir, it redirects a portion of a river into a small dam. This approach sacrifices the reliability of water flow from across seasons that the storage approach guarantees, but it minimizes the impact of large dams.
In hydroelectric power, we use the kinetic energy of moving water to turn turbines and generate electricity. It's the most widely used form of renewable energy, accounting for 16% of global energy generations and 2.2% of the world's energy supply. Nations abundant in river water and the resources needed to build dams can effectively use hydropower as an alternative to fossil fuels. Its cost of production is also very low compared to that of fossil fuels, making it viable as an alternative energy source. Many nations, such as the United States, have been constructing dams since the 1930s in order to harness hydropower due to its cost efficiency and its indirect role in mitigating environmental damage.
Positive effects of hydropower includes clean and renewable energy with an EROI of 10.1 or higher. And there's also little air pollution that goes into making hydropower. However, there are also negative effects. Reservoir buildup leads to the release of methane gas in anaerobic deep water, as well as flooding being suppressed, so floodplains are deprived of nutrients. There's thermal pollution, migrational offset of the fish and animals that live in the rivers, and uneven water distribution. Fossil fuel is also used to maintain and build the dams in the first place, and there's also habitat destruction from building these dams.
One of the newest forms of hydropower is tidal power. But first, what are tides? Tides are the rise and fall of sea levels caused by the combined effects of the gravitational forces exerted by the moon, the sun, and the rotation of the earth. While the moon may be hundreds of thousands of miles away from us, and the sun millions of miles more, they both have a major effect on our oceans. There are two main ways of harvesting tidal power: tidal stream generators and tidal barrages. Steam generators are cheaper and less environmentally damaging, but return much less power than a tidal barrage. They are basically underwater wind turbines, but rather than being powered by wind, they are powered by tides. They can either be mounted, tethered, or floating near the surface. There are various makes and models, but most of them have the same pros and cons. Most are minimally harmful to the environment, since most fish will avoid the turbines, and the majority of the negatives come from the creation of the bases for tethered and mounted turbines. Tidal barrages, on the other hand, are dams across bays or river mouths. However, unlike a conventional dam, they allow water into the reservoir during high tide and return to the ocean, whilst driving turbines, during low tide. These tidal barrages have the same benefits as dams, but with additional negatives.